So good evening, everybody. Welcome to this evening's LJC event. For those of you who don't know me, my name is Abby and I work with Barry Cranford, who's the founder of the LJC. I have the privilege of hosting today's event for you. The LJC stands for the London Java Community, just in case you weren't aware of that, and it is just one of 15, I think, tech communities that is currently run by RecWorks. We are a tech recruitment company with a massive difference. So as a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach or share their knowledge, we are happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we've run over 700 events for engineers and developers, students, graduates, and CTOs. We have run conferences, lightning talks, hackathons, all sorts. In January this year, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited to hit our 5,000th introduction through that community as well. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our communities, get in touch with myself, Barry, or Helen Lewis, if you know her, and we can take it from there. The recording of today's session will be available on YouTube, and towards the end of the talk, I will put the link to the YouTube channel in the chat, along with my LinkedIn profile. You can always message me and I'll send it to you when it's ready. As regards questions throughout today's event, if we will have time for Q&A at the end, so if you think of anything while Whitney's speaking, please make a note of it, and then we'll have time for a Q&A at the end of the event. So with no further ado, I will hand over to Whitney to introduce herself and give us her amazing talk. Over to you.
Hi there, I'm Whitney. So nice to meet you. I'm a developer advocate at VMware, and I focus on Kubernetes related things. And among other things, I'll talk about this later, but I have a streaming show called Enlightening, where I use my lightboard to, a guest will come on my show and teach me a cloud related concept, and I'll draw out my understanding as I learn it. Today I came on to give you a talk called Who Should Use Kubernetes, which is a talk that I give at conferences. I've given it only a couple times so far, and I usually speak at slides, but I practiced my talk last night with my brother. My brother is a senior developer at Twitter, and he knows zero things about Kubernetes. And so his advice to me was that the launching point for the talk is a little bit, it assumes some amount of Kubernetes knowledge. And since I'm talking to a room full of developers today, I thought it might be fun to add on a beginning part, a preamble to the talk where I go behind the lightboard and talk with y'all about how Kubernetes works. So I'm going to pick you up on my laptop and we're gonna go back there together. And I'm gonna, we're improvising now. So I feel pretty vulnerable, to be honest, but in the name of progress over perfection, let's see how much of a Kubernetes overview I can give right off the bat. So you're sitting next to me behind my lightboard. You can see my streaming desk behind you in the background. I'm turning up the lights on my lightboard area. So another thing here is I'm used to hosting a streaming show. So I'm used to having constant feedback from the chat and questions from the chat. So for this part, this oh, look, you can see me, here I am. For this part, I'm gonna put the Zoom chat here loudly. Oh, hello, Lisa, hello, Ingo. And I'm gonna be able to see your chat. So while I'm talking about Kubernetes, or while I'm behind the lightboard drawing, I'm turning on my second monitor now. I would love to be able to chat with you about it while I do it and maybe get feedback. So let me confirm, yes, I can see you, hello. So if someone will type something in the chat, we can confirm that I can indeed have a live feed of what y'all are thinking and saying. Yes, howdy, Lisa, thank you so much. So we're gonna talk about what even is Kubernetes? I would love a show of hands to know, like, who already kind of feels like they know the basic architecture of how Kubernetes works? Yes. And so meanwhile, I'm going to talk about Kubernetes from the aspect of creating a pod, because I think everything for me resonates more if it's kind of a story. So Kubernetes is distributed computing. So it works across multiple computers. So I'm going to draw out our computers here. So this is a control, it's called a node, a control node. So this will host control plane components of Kubernetes. And in our example here, we have one, but I guess in a production level cluster, you'd want at least 3 of them for high availability. So we'll draw 3. So we have a control plane here. So these are our control nodes. I hope y'all are having fun. I'm not used to doing this where I'm the one teaching. I'm usually hosting a show where other people are telling me what's up. You can see I'm a little nervous because my hand's a little shaky. So these are our worker nodes. So these are computers that are going to host our application workloads. So we'll label them as such. So I'm me, and I want to make a pod. A pod in Kubernetes is the smallest unit of compute. There's me. There's my long hair and my bangs. That's me. And I want to make a pod. And pod is the smallest unit of compute in Kubernetes. And inside the pod is where our application runs. So when I want to make a pod, I'm going to run a kubectl command. There are lots of ways to do it. But if I'm doing it on the CLI, I'm going to run a kubectl command and say, I want to make a pod. And so that request is first going to be validated and authenticated. It's going to say, who are you? And do you have access to this cluster? And then it says, oh, you're Whitney. Yeah, come on in, do whatever you want. And then that request is going to come in to the Kube API server. So the Kube API server is the main management component of the Kubernetes cluster. It receives my request to make a pod, and the first thing it's going to do is write that request to etcd. So etcd is a distributed key value data store. And among other things, it holds both the desired state of the cluster and the actual state of the cluster. So the Kube API server says, we want to make a pod. It tells etcd, etcd writes to the desired state, Whitney wants a pod, and then etcd returns a successful write to the Kube API server. And so at that point, the Kube API server already is going to return to me pod created, even though not a lot has happened yet. So I get a message that it's made and hardly anything has happened. But because it's registered with the desired state, it's as good as done as far as the Kubernetes cluster is concerned. So the next component I'm going to talk about is the scheduler. The scheduler is specifically watching for workloads that need to get created. And it's a control loop. So the default, I believe, is every 5 seconds. It's going to be like, it's asking the Kube API server, hey, are there any pods that need to be made? No? Okay. How about now? Are there any pods that need to be made? No? So then it's like, one time I checked and it's like, oh, we do have a pod that needs to be made. Whitney wants to make a pod. Let's do that. So the scheduler is first going to roll out any worker nodes that are unsatisfactory. So they could be unsatisfactory because of like maybe the cluster administrator said only these certain nodes are off limits to Whitney, or these certain nodes are only for data heavy workloads. So there could be rules set up. And then it's also going to rule out any that maybe don't have enough space on them, for example. And so once it's ruled out nodes that don't work at all, then with the nodes that are left, the worker nodes that are left, it's going to run a scheduling algorithm and use that to determine which node my pod should run on. So schedulers figured it out, but I want to pause right there and talk about the worker nodes and what's going on with them on their own without the actual workload running. So a worker node has 3 components. So the first one is the Cubelet. So the Cubelet is the point of contact between the Kube API server and the worker node. It's going to register the node with the cluster. It does periodic health checks and communicates that information back to the Kube API server. And it also creates and destroys or updates workloads on the node as directed by the Kube API server. And then every worker node, it also needs a container runtime engine. So that used to, when back in the day, it used to always be Docker, but now it can be any container runtime engine that is compliant with the Container Runtime Initiative. So container runtime engine. And then each worker node also has kube proxy running. And that enables communication, like inter-node communication. Okay, so that's what's going on a worker node on its own. As far as my pod getting made, the scheduler knows where it wants the pod to go. And then the scheduler, does it put the node on the pod? No. It tells the Kube API server which node my workload should go on. And then does the Kube API server put it on the pod, on the worker node, excuse me? No, because the Kube API server is going to write it to etcd next. So etcd currently knows it has in its desired state, Whitney wants a pod, and now it's going to update the desired state to say Whitney wants a pod, and the scheduler says that pod needs to be on node 2. And so now the actual state is out of sync with the desired state, and the Kube API server knows, okay, I'm going to direct the kubelet to spin up Whitney's pod on worker node 2. And so the kubelet gets made. Let's make it pink. I said the kubelet, but the pod gets made, and then the container is running inside the pod. And now I have a running application in Kubernetes. So now the kubelet is going to tell the Kube API server, hey, your pod's created. The Kube API server tells etcd, hey, the pod's created. And now all is well because the actual state is now equal to the desired state. Now you may have noticed this already, but no 2 components in Kubernetes really talk to one another as far as, especially on the control plane. Everything talks to Kube API server. It's the management component, so it's orchestrating everything. So now we have the use case of, like, one of the things Kubernetes is known for is resiliency. So let's say my pod, something happens and my pod goes down. Well, now the kubelet sees the pod goes down, the kubelet tells the API server tells etcd, and now we have our actual state and our desired state out of sync. So what happens next is, we have to have on my pod, let's say I set the restart policy to always. So now we have another component that comes into play, and that's the controller manager. So the controller manager is made up of many controllers that are each watching a different piece of the Kubernetes system. So the replication controller specifically within the controller manager is the one watching that the number of replicas of pods that is desired is also what is actually reflecting in the actual state of the cluster. So the controller manager, again, just like the scheduler, is pinging the API server at regular intervals, checking the status. And so at some point, it's pinging the it's pinging the Kube API server. The Kube API server reports that this pod is not here, and then it knows, the controller manager says, hey, you need to be spinning that up, and then my pod gets spun back up. So Kubernetes is like just a zillion control loops, making sure the desired state is equal to the actual state. A couple of things I want to mention. There's also, if you're running your Kubernetes cluster on a cloud provider, which you almost always are, there's a cloud controller manager. And that is watching the components that are specific to the cloud resources, which is usually a load balancer or the actual servers, the machines themselves. And then my talk, when I give it here in a moment, has a lot to do with Kubernetes resource objects. So a pod is a Kubernetes resource object. And then if we have several pods running at once, or even if we don't, if we have a defined set of pods, so it could even be one, but if we have a set of pods that we want to keep running, those will go together in a replica set. So if you want always to have at least 3 pods with your application running, you would that could be defined in, it is defined in a replica set. And then the replica set itself is inside of a deployment. And the deployment will define things like rolling, like rolling updates, like how your application is updated. So we have a replica set. So we have a replica set controller that's watching to make sure the right number is up all the time. We have a deployment. A deployment could have one or many replica sets. And when it rolls out a new application, it does that by making a new replica set and bringing pods down from the old replica set and up into the new replica set, for example. So we have a deployment object. And then we'll have other objects like a config map or secrets to help give like environment variables to our application. We have a service to help have only one endpoint for everything in our application, because a pod is ephemeral. So once it goes down, it's not like the same pod gets repaired and it comes up. A whole brand new pod comes up with a brand new IP address. So you have a service keeping track of which IPs are associated with which application and load balancing between all the pods on that application. I'm throwing a lot of information at y'all and no one's asking me any questions. Yes, I guess it's not normally a streaming thing. So I think that's maybe all I want to say. We could talk about, so this is a deployment is for a stateless application. If you have a stateful application, instead of using a deployment to wrap your replica set, you would have a stateful set, and then you could attach storage. So that's another Kubernetes resource object, a persistent volume or persistent volume claim that you would use in Kubernetes. And again, those resource objects are each being watched by different controllers. And then when you want to extend the functionality of what Kubernetes can do, you do that by adding custom controllers and custom resources. So that gives the foundation for my talk. And do you have any questions while I'm here behind the lightboard? Otherwise, we'll save the rest for the end. All right, I'm going to move back over to my streaming desk. Thanks, everyone. All right, let me get my camera back on. Sorry about that. Here we are. Oh, I got a question. That's wonderful. Hold on just a moment. Which components manages config maps and secrets? That's a great question. Mauricio, I see you're on. Do you know the answer to that? Aha, there are controllers for that. That's pretty much the answer to everything. There are controllers for that. There's some controller somewhere is keeping an eye on that resource. Let me turn this off. And making sure the actual state is equal to the desired state. All right, I'm going to close the chat now. I'll be out of touch. And I'm going to bring up okay, I feel ready. I'm going to share my screen. You're going to see some, I chose wallpaper that looks like literal wallpaper. And who should use Kubernetes? Does everyone see a big, I'm asking a question, but I honestly can't see chat. So I trust, I trust you, Abby. Okay, great. Cool. So here we go. Who should use Kubernetes, friends? The idea for this talk started with a question that my developer friend asked me, who is Kubernetes for? And I was surprised to realize that I didn't know. I mean, I know Kubernetes is great to optimize costs and streamline operations for like enterprise-sized organizations. And I know Kubernetes is likely overkill for an app that someone's building on their own as a side project, but what about in between? Like, at what point do the benefits of Kubernetes outweigh the operational complexity? And what factors might an organization consider when deciding whether to adopt Kubernetes? So my name is Whitney. I feel like we're old friends now. And among other things, I host a streaming show on Tanzun TV called Enlightening. Each week, a guest comes on and teaches me about cloud-related concepts or technology, and I draw out the information on my lightboard as I learn. I ask tons of clarifying questions as we go, and it's a streaming show, so we always get a lot of great questions and comments from the chat too. This experience with my friend asking me, who is Kubernetes for, inspired me to make an enlightening episode called, Who Should Use Kubernetes? I invited my talented teammate, Lee Kapili, to be my guest and come on the show and answer these questions. So Lee and I had a super fun stream where we discussed Kubernetes. We heard a lot from chat about their experiences, including a literal server fire, and the episode ended with Lee doing a cartwheel. So that's the starting off points for my talk today. So who should use Kubernetes? But before who, let's talk about the what and the why. But before we'd even do that, my time is pretty limited today, so I'm going to declare some topics off limits. So we're not going to define Kubernetes as a container orchestration platform. Granted, that's an absolutely valid way to describe Kubernetes and the way it's most often described, but that's not how I'm going to talk about it today. We're not going to talk about cost optimization. Cost optimization is indeed a big benefit of Kubernetes, no doubt, but don't you dare mention it. So Kubernetes will help to make your applications fault tolerant, partly because it automatically restarts failing containers like we were talking about before. You're just going to have to trust me on this one, though. It's not the time to discuss it. Kubernetes scales applications based on resource utilization, but don't ask me anything about it. We're not going there today. In fact, here's a bunch of other benefits of Kubernetes that are also off limits. This is not the point of today's talk. Right now, I'm going to talk about an often overlooked benefit of Kubernetes and arguably the most important one, the big idea. But before I do, what is Kubernetes besides a container orchestration platform? Kubernetes is a software that knows how to run software. Kubernetes is a software that knows how to run your containerized applications. Kubernetes is distributed. Kubernetes has one interface, yet it runs across multiple computers at once. With Kubernetes, you can turn lots of computers into one cohesive idea. Kubernetes is also declarative. You define your system's desired state, and Kubernetes works to bring that state into being. And doing so, Kubernetes stores your way of working. So let's say it again for those in the back. For the purposes of this talk, this is how I'm defining Kubernetes. Kubernetes is a distributed, declarative software that knows how to run your software. Keeping this definition in mind, here it is, the big idea, the often overlooked benefit of Kubernetes and one of the most important benefits. Kubernetes helps people work well together. Kubernetes provides a consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates a clear separation of concerns. People who use Kubernetes can understand how the parts of the system that they touch relate to other teams and to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. Okay, I've been going on about declarative, but to help understand what problem a declarative way of working helps to solve, let's talk about the opposite of declarative, imperative. To illustrate imperative versus declarative paradigms, let's consider a scenario where you ask me how to get to the library. If I answer imperatively, I would give you a series of steps as an answer. Step 1, go west on Riverside. Proceed for 2 miles. Step 2, turn right on Congress. Proceed for 2 blocks. Step 3, turn left on 2nd Street. The library will be on your left. This is all very sensible, but also is highly dependent on circumstances. What if you go to lunch before you go to the library? These directions are no good without the proper starting point. What if Congress Avenue is closed for construction today? You're left with no recourse. If you ask me how to get to the library and I did give you a declarative answer, I'd simply give you the address to the library and a map. It would be up to you to choose the best steps given your circumstances at that moment. Okay, Whitney, you convinced me. I understand imperative is bad, but what does an imperative system look like in practice? I'm going to answer that with one word: scripts. Imagine you're in charge of creating and maintaining environments that host applications. You need a consistent way to install apps and their dependencies on several different computers. Before Kubernetes, the answer for this problem was big, long bash scripts. Scripts to install operating systems, scripts to install applications and dependencies, scripts to configure the environment. If the server restarts, scripts are used to restart all of the applications that should be running. More scripts are needed to make sure that everything restarted correctly. If a script gets changed, how do you reliably update that script across the entire estate? What happens if a vulnerability is discovered? What happens when web traffic grows and you need to scale up? One way to imagine how difficult and tedious it must be to be an operator of a system that's run imperatively is to imagine that you're in charge of making sure that 2 laptops are exactly the same. And you're also in charge of keeping them exactly the same indefinitely. Did you install and configure software on one? Do the same for a second. Did you change the permissions on the first laptop? Did you update which apps you want to be able to notify you and why? Make sure you're capturing all of that and making those same adjustments on the second laptop too. I get it. Kubernetes is awesome because it's declarative. But wait, what does declarative mean? What does a declarative system like Kubernetes look like in practice? I mean, I understand that with Kubernetes, you define the desired state of your system, but what is being defined exactly? Defining the desired state of your system is pretty broad. How is the desired state of your system being defined? And who's in charge of defining it? It seems like a tall order. The desired state in Kubernetes is defined using Kubernetes resource objects. Kubernetes resource objects are persistent entities in the Kubernetes system. Kubernetes uses these entities to represent the state of your cluster. A Kubernetes resource object is a record of intent. Once you create the object, the Kubernetes system will constantly work to ensure that that object exists. By creating an object, you're effectively telling the Kubernetes system what you want your cluster or its workloads to look like. This is how you define your cluster's desired state. If you're a developer, you're likely interested in Kubernetes resource objects that most closely touch your running application. So here's a quick overview of some Kubernetes resource objects that are used to define how a containerized application is to be run, accessed, and configured by Kubernetes. So you can define how you want to do scaling, rolling updates, and rollbacks in a Kubernetes resource object called a deployment. Within a deployment, a replica set resource object is where you define how many instances of your application you want to be running at any given time. A pod is the Kubernetes resource object that is the smallest unit of compute in Kubernetes. A pod hosts your running application. But at this point, the running application isn't accessible. A service resource object provides one stable endpoint that you can use to access one or many pods that are running your application. But that only provides access from within your cluster. To access the application from outside of your cluster, you need a Kubernetes resource object called an ingress. You can define configuration for your pods with the resource object called a config map, and define secrets for your pods with Kubernetes resource object called a secret. Those were some Kubernetes resource objects that you're likely to encounter as a developer, but there are many more. Namespaces, persistent volumes, limit ranges, resource quotas, network policies, roles and role bindings, nodes, service accounts, pod security policies, and many more. There are over 50 in the most recent release of Kubernetes, and there are many, many more, thousands more when you consider that the objects that you can make with other open source projects in the Kubernetes ecosystem. I'll talk more about that later. Right now, though, the point is that Kubernetes provides a way to declaratively define a lot of different aspects about your application and about your system. Kubernetes resource objects fall under 5 umbrellas. The workload Kubernetes resource objects are responsible for managing and running your containers on the cluster. Objects like pods, jobs, deployments, stateful sets, and replica sets fall under this category. The service Kubernetes resource objects are responsible for stitching your workloads together and making them accessible to traffic. Objects in this category are services, ingresses, and endpoints. Configuration and storage Kubernetes resource objects are used to create resources that are responsible for injecting data into your applications and persisting data externally to your container. Some examples are config maps, secrets, and volumes. The Kubernetes resource objects that fall into the metadata category are responsible for configuring the behaviors of resources within the cluster. For example, horizontal pod autoscaler for scaling workloads, limit range for limiting the resource use of containers in a namespace, and pod disruption budget for specifying how many replicas of a given workload can be made concurrently unavailable when performing maintenance. And finally, the cluster Kubernetes resource objects are responsible for defining the configuration of the cluster itself. Here we have objects like namespaces, roles and role bindings, service accounts, and network policies. Remember the big idea? Kubernetes helps people work well together. Specifically, Kubernetes resource objects are integral in helping people work well together. Kubernetes resource objects help to create a separation of concerns and also a standardized way of working among people and teams who do share concerns. Different people within an organization care about different Kubernetes resource objects, and there is some overlap, as you will see. A site reliability engineer is in charge of making sure that things are working for our end users. They care about Kubernetes resource objects such as network policies, roles and role bindings, namespaces, and horizontal pod autoscalers. An infrastructure engineer is responsible for provisioning hardware and installing Kubernetes. They care about Kubernetes resource objects such as network policies, nodes, and certificate signing requests. A database administrator cares about database instances, migrating data, expanding hard drives, and accessing data. They care about Kubernetes resource objects such as volumes, storage classes, persistent volumes, and persistent volume claims. A cybersecurity engineer cares about security policies, access and authorization, and providing identity to workloads. They care about Kubernetes resource objects such as pod security policies, service accounts, roles and role bindings, and ingresses. An application developer cares about the objects that I mentioned earlier, Kubernetes resource objects that touch their running application, such as pods, deployments, services, and config maps. Before Kubernetes, developers used to just send the binary to operations teams. Developers now feel closer to production because they understand how it will behave. As a result, they naturally adapt their designs for production. But what about the complexity? Kubernetes is notoriously difficult to install and maintain. The complex details of installing and running Kubernetes are increasingly being abstracted away. Many cloud providers offer managed infrastructure, also known as infrastructure as a service. With managed infrastructure, the cloud provider is responsible for servers, storage, and networking, while you manage layers on top, such as running a Kubernetes cluster. Or if that's too much work for you, there's also platform as a service. Platform as a service is Kubernetes itself as a managed service. These days, you can set up an initial cluster with a cloud provider in just a few minutes. With managed Kubernetes, your cloud provider is responsible for the Kubernetes control plane, as well as the servers, storage, and networking that is provided with infrastructure as a service. It's true, I won't deny it. Kubernetes is complex. It may be hard to set this all up, but it is worth asking yourself, what am I doing right now with my current system? Is setting up and using Kubernetes more complex than that? Kubernetes also has a vibrant ecosystem of tools and add-ons in the form of other open source software. These are tools that can be added to your cluster to help you do things like extract away complexity, or add observability or additional security, or that can supercharge your storage or your messaging or your databases. You can add additional software to improve the areas of Kubernetes that are important to your particular business. All of these tools are built upon the Kubernetes resource model that we talked about earlier. These tools work by each creating their own Kubernetes resource objects. Kubernetes is becoming mature and best practices are emerging for common problems and issues. For example, use a software called Bolero for making backups of your Kubernetes clusters. You don't need to worry about how it's done. The open source communities have figured it out. Or tools like Crossplane that leverage the Kubernetes resource model to enable you to define infrastructure across cloud providers in a Kubernetes way. Kubernetes helps people work together because Kubernetes provides a consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates a clear separation of concerns. People who use Kubernetes can understand how the parts of the system that they touch relate to other teams and to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. Okay, that all makes a ton of sense, but I still have another question, and this one is important. Who should use Kubernetes? And the answer is, perhaps you should. Let's go over some common pain points that Kubernetes helps to solve. Are you having issues because there's a mismatch between your production and development environments? If so, you should use Kubernetes. Developers can use Kubernetes in their dev environments, and in doing so, they will have a better understanding of how the production environment will work. Are you suffering from not having a standardized way to communicate across teams, resulting in operational toil? If so, you should use Kubernetes. If you use Kubernetes, no matter in which language your application is written, it is configured and run using the same mechanisms. For example, both developers and operations teams use a config map object to set and tune an application's configuration. Is your infrastructure complex and difficult to manage? Could you benefit from standardized infrastructure? If so, you should use Kubernetes. The Kubernetes ecosystem has many tools to help with that, tools that codify and version your infrastructure. For example, Argo CD and Flex CD. Side note, my Enlightening episode tomorrow is about Argo CD. When your applications need to scale, is the process slow, complex, and risky? If so, you should use Kubernetes. Kubernetes helps to automate scaling using resource objects like the horizontal pod autoscaler. An open source software called Knative further improves this process. Do your end users experience downtime? If so, that's a sign that your infrastructure could use improvement. You should use Kubernetes. The deployment's Kubernetes resource object itself was created with that in mind. It has a rolling update mechanism, and it's easy to roll back if there's a problem. Do you feel locked into your cloud provider because it would be too complex to move? If so, you should use Kubernetes. To make your system cloud agnostic, you can rely on the Kubernetes API instead of using cloud provider tools. Does your company's operational knowledge exist only in people's minds? If so, you should use Kubernetes. The Kubernetes resource model helps you to define your operations in a concrete and standard language. It is common practice to store and version this knowledge in Git. Formalize that knowledge and keep track of it. In conclusion, an often overlooked and very important benefit of Kubernetes is that Kubernetes helps people work well together. And for that reason, any growing organization should consider incorporating Kubernetes into their operational model. That's the end. Thank you so much today for your valuable time and attention. If you like, please follow me on Twitter, and please do check out my show, Enlightening, tanzu.tv/enlightening. Thank you so much.
Thank you so much, Whitney. That was amazing. So good to hear. And I love your graphics as well. That always makes me happy. Does anybody have any questions for Whitney? No, you've obviously explained superbly well.
or terribly. It really isn't one or the other.
No, I'm sure it's the former. I'm sure it's the former. I'll just give it one more minute. Anybody have any questions or comments that you want to unmute and share?
I see some in the chat. I get some thank yous. You're very welcome. Thank you for the nice comments, everyone. Craig McDonald says, are you aware of customers running Kubernetes on-prem rather than in the cloud? Yes, that's the short answer. Because of scaling different applications, it still has that benefit, even if your infrastructure, your actual physical machines are pretty heavily defined. But it also helps to, it's bin packing, so it helps you to get the most out of your machines, to fill them up completely. The algorithm can take care of that. And then it also helps in all of the ways that I talked about before, in terms of helping teams communicate with one another and define and share responsibilities, off the top of my head.
And Maurizio's just said there are loads of companies running on-prem due to policies and compliance matters.
Oh, yeah.
So
yeah. Thank you, Mauricio.
Do you have a YouTube channel?
Let me share my show. I thought I opened it. Here's the show. So you can come here. Is probably the best place to see all of the upcoming episodes. Actually there you can also get some my profile, and I'm starting a YouTube channel. It only has 3 videos. And so we'll see. I'm trying, and I have to have like so many users before I'm even allowed to have a real channel with a real name that's just not a bunch of random letters and numbers strung together. But if you go to my profile from that Enlightening link, you can find a link to my YouTube channel there. Oh, Lisa said she'll sign up. Thank you so much.
I would sign up too, just to see some more of that cool whiteboard stuff. It looks amazing. Excellent. Well, from the looks of things, nobody has any further questions. So all that remains is for me to say thank you so much, Whitney, for coming and sharing what you know. We'd love to have you back another time if you're up for that. That would be amazing.
Yeah.
And
thanks so much.
Thank
this
you.
has been tremendously fun.
Yeah. Yeah, excellent. I'm glad you think so. That's great to know. And thank you, everybody, for coming and joining us for today's talk. And like I say, the YouTube video will be available shortly, or message me. I will just get the links for you in the chat before I close us down, so that if you want the YouTube, you can go directly to our YouTube channel, or like I say, message me on LinkedIn and remind me that it was this talk you came to, and I'll be able to get that sent over with no problems.
Looks like we have a question in the chat from Boniface. I mostly find Kubernetes talked about in relation to systems created with microservice architectures. Does it make sense to run using a monolith? So the answer to that question is, in order to be able to containerize, basically Kubernetes runs containers, and it's hard. Oh, here we go. Yes, it does with monoliths, says Mauricio, if you're planning to extend them using decoupled services. So basically you need your application to be able to be run in a container to be able to use it with Kubernetes.
Fabulous.
Thanks for the great questions. Yeah.
Yeah, it's brilliant. It is brilliant to have some good questions as well, isn't it? Great to have backup as well when you're answering them. It's excellent. You guys are doing a great job. Thank you. So you should now see the link for the London Java Community YouTube channel in the chat, along with my profile on LinkedIn. If you want to get in touch, please do. I'd love to hear from you. Oh, we've got another question. So what's the advantage of Kube versus Docker Swarm?
I know of Docker Swarm, but I don't know enough about Docker Swarm. But I can say that it's just fun because Mauricio's, okay, Docker Swarm is dead, says Mauricio, and Kube is the de facto standard in the industry. But I'll build on that and say Kubernetes has such an amazing ecosystem of add-ons and tools that you can use with the technology. So you can extend it in ways that are very custom to your personal use case. And I'm pretty certain that Docker Swarm has nothing like that.
Fabulous.
Yeah.
Any other questions before I really do shut us down? Okay, well, like I say, thank you so much, Whitney, for coming and sharing what you know, and Maurizio for chipping in there where we needed you. That was excellent. Yeah. And thank you, everybody, for joining us this evening. I hope you have a really great rest of your evening and look forward to seeing you at some other LJC events as well. Take care. Have a great one.
Thank you. Bye.
Thanks so much. Bye.